We might just get started. As people come in, they'll come in. So this could mean that as a workshop, but they had this birds of a feather thing. I was throwing it in as birds of a feather. This audio is being recorded, by the way, so I may use it for a Biota recording or what have you. So please be aware of that fact and talk accordingly. You will, of course, be censored, and unless you state your name, no one will ever know who you are. So it's a good way of starting. Do any of you have a definition for what an artificial life hobbyist is? Very good. So I've done a bit of research on the term because I was part of the initial coining. I'm Tom Barbalet, by the way. Barbalet is my artificial life hobbyist simulation. I've been developing it for more than 16 years now. It's been used by Apple and Intel and hopefully Netflix, who's my current employer. And it simulates, the red dots are ape-like creatures wandering over an environment. As you can see, there's tides, there's a weather simulation behind it. This is all fractal as well, so I'm just going to throw things in disorder and create a new environment. So a wide variety of components to Noble Ape. I've published on it academically, which is part of the hobbyist definition as well, but historically there was no meaningful definition for what I did. In 2005, I picked up the Biota.org site. Are we familiar with Biota? It was a Biota conference series. Dawkins, Douglas Adams, a wide variety of people attended in the late 90s, early 2000s. And then basically the site went dead. And about 2005, Bruce Damer, who ran the site, contacted me because I'd been periodically pinging him saying, could you update the site, could you update the site? Finally, he had a project that had taken enough of his time that he passed the site on to me. I started doing text interviews initially, and then I did a series of audio interviews. Might as well the site as well. So I've released it as an internet radio show or podcast. FreshSim is a group that came out of Biota. It's an artificial life forum. But what you have on here is a series of interviews with luminaries and other folk. This is the Biota Live, which was the internet radio show. Jeff Clune, who talked about a wide variety of folk and ideas taken in an internet radio recorded format. So biota.org, in this case, /podcast. And through this definition, there were a group of people who had previously been academics and now were no longer academics but were maintaining their artificial life simulation. People like, well, Larry Yeager is an interesting example, but he's kind of moved from industry back to academia, but there was a period of time where he was in industry. And a number of us didn't fit the standard profile associated with artificial life academic, so there was a need for another term. And slightly tongue-in-cheek, a couple of us coined the term hobbyist to describe these folks that had long-term artificial life simulations. I work on Noble Ape probably between 6 to 12 hours a week in terms of the underlying simulation elements. I have a full-time developer who's a roboticist in the UK called Bob Mottram, who's added a lot of the kind of social robotics elements to Noble Ape. So the social graph elements that you see here, the honor, for example, the drives, which is simply Israel at MIT, are all elements that come from Bob Mottram. Wide variety of components to Noble Ape. There's an internal simulation that covers heart rate, breathing. I use the metaphor associated with kind of model rail enthusiasts, but what you do is you take a biological environment, you zoom in on a certain area, you write a simulation associated, you take it further, you write a simulation, you step up. So in Noble Ape, in terms of the simulations, you have the landscape simulation, the weather simulation, you have a cognitive simulation, which you can see here, representing the ape's cognitive processes. It's a fast reactive simulation, so it's the fear and desire elements that the apes have. In addition, there's the social simulation, which I mentioned, which is the Cynthia Brazil, stuff with the honor and the hunger and fatigue and social sex drives. And then in addition, the apes have episodic memory. So what you see here is the apes experience this particular ape. They have human double-barrel names in Noble Ape. So you can get a list of of all the noble apes that are in the simulation environment currently and focus on a particular one. See the various things that are going on in this particular ape's existence in a particular time. So the term hobbyist has, like I said, first coined in roughly 2005. A fellow in the UK and I came up with the term. But since then, in large part through Biota, it's a term that a number of people have kind of picked up on and run with, because either they've not been in academia, they've not been in industry, or they've had long-term simulation that they've just maintained. There are central elements like open source. So the reason Apple first picked up Noble Ape was because it was an open source simulation, that they could just get the source code, drop it into their compilers, and it worked. Apple used it because there's a real-time graphics component and a tight mathematical core for various optimizations for their specific processor architecture and how you actually interact with the environment. When Apple lost that part, when they moved to the Intel processor, that technology and the Noble Ape part of that went to Intel, and Intel has maintained it from about 2005 through to, well, pretty well the present day. There's a team at Intel that's used Noble Ape extensively, and a number of smaller teams that have come up from it. So that's the definition of hobbyist. That's my project specifically. My hope was that there would be others here today that have similar projects or similar interests. I know you came to the first session. Would you consider yourself a hobbyist?
Yeah.
Would you like to talk a little bit more about?
Well, I mean, one of the goals I've had for about 15 years is developing something very similar to what you have here. Just unfortunately, real life takes precedence over artificial life.
Certainly.
So it's only just been little bits here and there that I intend to piece together, and I don't really get to, and then I write another piece, and then I piece that in. So I got my little bits and bobs kind of sit around.
So that was my legacy prior to actually starting Noble Ape. Was, as you say, I had all these little bits and pieces. I had a rich Petri dish simulation, which went into the cognitive simulation. I had a landscape visualization engine, which, from previous iterations went into that. The collecting of those things together actually produces, it's the idea of the gestalt, that all the pieces are more when they are all together. I can't really give you any meaningful motivation to do that, other than it will be, better than the pieces are individually. In terms of the legacy of the hobbyist, there have been a number of people that have certainly impacted on me, but in terms of your interests, where did this come from?
I don't know, it's been going for a while, and I sort of had kind of a embryonic kind of interest. Someone handed me Deep Brain's Creatures, and I was like, someone's done it. And I was like, well, why don't I just make something like this too? I didn't know from there.
So in terms of Steve Brand, absolutely fascinating fellow. I mean, you've probably had exposure to my conversations with him, or recorded conversations at least. So the thing with Steve Brand is he would be a hobbyist if he released his stuff open source. I was able to get one of his games. So do people know who Steve Brand is?
I know you're talking about the old game called Creatures 2.
Yeah.
That's the little eggs popping up.
So, aside from that, Steve Brand got heavily involved in robotics, and he's been periodically funded by various groups in the UK to do research, but he's now based here. He ran a, what's it called, Kickstarter's project.
Here you mean in this one?
No, in the US, sorry. He's in Arizona, I think, currently, but not academically affiliated there. He has a kind of hermit lifestyle, but he has people that come through and visit him, basically. I don't necessarily know how I editorialize his current life, but he got funding through Kickstarters recently to create a game. And he's been living off the proceeds from that pretty well for the past, I guess, year and a half. Do you know any more about the...
I did the Kickstarter thing for it, which got me access into his, basically, here's what's happening every day, to help keep up with it. He's working hard. He's just doing it a piece at a time. He's like, I'm doing the chemistry today.
Yeah.
I'm doing the neural simulation today.
So his game maybe 2 games prior to what he's doing for the Kickstarters, I was able to get him to release open source. So Synergy on SourceForge is that project. So that is a fully functional game that he developed. In large part because he wasn't going to continue to develop it, he didn't want to develop it anymore, but he thought it would be inspirational to others to be able to pick up the source code. And since then, most recently through FreshSim, which is the forum site that I run, a fellow, I think, will pick it up and run with it accordingly and actually produce something from it. He has a very simple existing artificial life simulation that uses the XNA element in it. So it'll be relatively straightforward for him to pick up Synergy and adopt all of those components. And interestingly enough, Synergy comes from his robotics, for Steve Brand's robotics project earlier as well. So the linking factors that you see in Steve Brand's work is analog electronics, relatively simple chemistry model, and a specially designed neural network. I think that's pretty well signature in all the things that he has done. And the stuff that he contributed into Synergy contained robotic elements as well in terms of actual connected parts. So Synergy is a game where basically you form living entities that have locomotion, consume energy, but they're from atomic components that are built together, and there are various reproductive rules and various inheritance rules. I'm not sure if there's a kind of backbling winning over component. I thought there may have been an element in that where if you killed another creature or what have you, you could then disassemble it and pick out bits as well. I think there's a kind of familiar theme in that element too. But yeah, Steve Brand is an interesting character, and certainly, aside from, he now has an open source project thanks to my efforts with Synergy. But aside from that, he still maintains a very tightly closed source model. I would consider him a hobbyist. But he's actually not true. Now I've said it out loud. He is a professional. But basically, he is very inspirational in the hobbyist community.
I was listening to his little post every once in a while, this humanity that inspires probably about maybe 100 or 150 people that follow him. Mm-hmm. They're equally inspired.
Mm-hmm. I think the notion of inspiration versus creating something is the thing that interests me. And he has a very his ability to generate money through Kickstarters relatively rapidly was phenomenal. He generated, I'm going to get the number wrong, but he generated a quite sizable amount of money very, very rapidly. But he did that because he had a following, he had books, and he also had a good success with a commercial game. In fact, a couple of commercial games, but one he had the most influence in. Other examples of hobbyists. Well, I think Jeffrey Ventrella is another good example. Are we familiar with Jeffrey Ventrella's work? Okay, Jeffrey Ventrella has attended a few artificial life conferences. His work relates to walkers, avatar elements, and swimbots. If you've seen evolving swimmers in a variety of Darwin Pond and Gene Pool are the two games that have come through that. And basically just the evolution of swimming, but also really interesting underlying elements. He has an element of racism, for example. So you can get mating selection based on similarity versus difference and these kind of things. So you can see what happens if it's a binary switch. You can see what happens if the swimmers have a particular disposition specifically to their own or to diversity, and what happens through those environments. So relatively simple. He did that as well as we've described with Steve Brand, as part of a commercial game project. I've also worked with him to move some of his work open source again. I moved a project he developed called Melody Ball, which is, it doesn't have an underlying genetic component, but could have an underlying genetic component. It's a notion of kind of spatial music. So you have a series of points in space that have angle components, and there's really no underlying artificial life componentry to it, but it just relates to a ball that drops and hits them and plays a melody basically as the ball moves around. Previously, and I think I don't want to concatenate his work here with Jonathan Klein's work, but he also has an evolving music component, which is a movement from Dawkins and the Blind Watchmaker. Anyway, the artificial life simulation Dawkins talks about the blind watchmaker, but with regards to music, so you can select spatially a series of songs and basically it'll play it for you. It has a graphical component to it as well, where you see the instruments, and you end up with these kind of hybridized instruments with sound literally flowing through them spherically. So Ventrell's work is amazing in terms of the kind of graphical characterization of it. He was at MIT Media Lab. He has a very keen visual sense, and he's taken that on to his projects following. Other people in the hobbyist community, Dave Kerr is another good example, complete hobbyist, no connection with academia, no connection with industry. He developed a project called AI Planet through the 90s, where you could program your own creatures into the environment. But these were creatures that had visual representation. So you could create what they call rubber ducks, for example, or tigers, or walking palm trees. And it was completely open source. It was a platform. Unfortunately, it ran on Delphi, which was the only downside. But people had contributions to it, and the planet grew progressively as the contributions were added. And all these components interacted. The person who introduced the tiger basically killed off a whole series of other things, and then they had to create separate planets. There was a political kind of forum aspect to it as well, associated with how you would actually introduce, swans versus, fire-breathing ants and all these kind of things. But it was picked up by the alternative dance music rave scene at the time, and it became, people would make T-shirts with AI Planet, and it became kind of an external thing that brought people back into it as well. Dave is an interesting example because he has always wanted to integrate with the academic community. In the previous, I've been giving workshops all day. In the previous workshop, we were talking specifically about what biologists need to do in order to embrace these kind of hobbyist projects, because they're fundamentally non-academic. They're to scratch an itch there, although a number of people, Jeffrey Ventrell, myself, and Steve Graham publish academically, they're not your traditional, here's a biological system, here's a simulation representation, let's change the simulation representation to try and map it onto another biological system. It's not that kind of thing. You're actually scratching different itches, basically. But what comes through that is something that biologists could equally study and learn something that they could then map back to some other system. The problem with the biological simulations that was described in the last session by the fellow who attended was that biologists don't currently do this. They don't see these artificial life systems almost like biological systems. And the underlying studying element associated with that, there needs to be some kind of descriptive change. That's really why I kind of brought this meeting together, was to give a sense that there's a lot of artificial life stuff out there that wouldn't normally fit into an ALIFE conference, but should be of some degree of interest. And
that's actually a question, is how, so as a biologist who works with undergraduates, who are quite playful, and who would embrace this sort of thing, where do I start? How do I guide them into useful projects at an undergraduate level, messing with these or other very, very similar things? I think that would be a venue where maybe with a graduate student, they're going to be maybe a little more interested in things that maybe are more biological. But with undergrads, the more playful it is, the better.
So I'm interested in that as well. Here's the way I do it, because within a month's time, a period of a month, I can be contacted between 2 to 12 students, sometimes undergraduate, sometimes graduate, that want to get involved in Barbalet in some way. And the difficulty is that I don't have people such as yourself. I just have my own interaction with them, and I have a mailing list set up, and they can email other people that work with Barbalet and have other things solved through that. But basically, your point is critical, because you provide the biology, and we provide the environment, basically. So, you probably need to interact with these things as well and get a sense of them. But if they bring them to you, so much the better. Now, the way I have used Barbalet historically, and the way it's been picked up by universities that want to teach various things, typically not things that are biologically related, typically how you get software into large companies or multimedia, real-time processing, these kind of things, then there's always been a guiding element, but basically I will provide full support as well. So in the case of coursework, for example, there was a fellow, University of Southern California, San Diego, but it wasn't University of California, San Diego. Anyway, he had a class associated with multimedia learning. And Noble 8 was one of the things that he set for the students to look at. And a combination of students, it was an interesting course because some of them were teaching-related students, others were just general BA students, wide combination of students, and they all took a different approach at how they... But it required his prompting on one regard and my assistance on another regard. So Noble 8 was a lot of documentation. You can take it to any level you want. There's published documentation, there's academically published documentation, there's a wide variety of stuff available online. They all explored a different element. So the teaching folk who were in that course got the original manuals, which detail the reasons that went into Noble 8, background philosophy, all the kind of depth stuff, written in 1997, available on Amazon for $6 or something now. They went through that and created coursework based on that. The BA people were more interested in the multi-layered cooking and simulation philosophy aspects. So one of the things I do in Noble 8 is philosophical satire. Philosophy has all these artificial dichotomies, which are just nonsense. So I put the dichotomies together and say if they're in the same simulation, go. They're there. What you say is opposing, what you say is opposing, actually can coexist and give you more interesting results. Visual arts took another aspect to it and these kind of things as well. So your interaction is critical, but certainly I'll provide support. And I think historically, some of them, and in terms of real world, the folks who've had children who've done artificial life development, you may not get necessarily the depth of support that you would get with someone like me, but you will typically get enough information. There are a wide variety of projects out there, and I think the play element is critical. So if you say to them, find an artificial life simulation, a lot of them existing games too, but, non-games as well, the stuff, that I do, these kind of things, and start exploring what assumptions are made, for example, or what level of biology is this element simulating, or describe how the weather affects the blood pressure, or all these kind of things in the simulation context. Is that backed up by certain science? You can do this at any level. When I first started developing Noble 8, there were a number of 10 to 15-year-olds who would contact me about learning to program with Noble 8. Here's an interesting thing. I'm wearing the old school Noble 8 t-shirt. There is a new Noble 8 logo. Within the past 4 months, I was contacted by a fellow who's an artist on The Simpsons. He's actually their highest artist for background drawing, what have you. He wanted to learn to program. He picked up, I think, by a podcast or something, and he contacted me saying, I know you're extremely busy, but would you be interested in using Noble 8 to teach me how to program? And I said, sure. Went through, found this guy's references, and after doing that process, because there's a lot of it's written in C, fundamentally, there's Objective-C over that, for the Mac version. He drew a number of representations of the Noble 8. So I now have new graphics associated with that. But these kind of interactions don't typically happen. He's a rarity now. But you see, and 15 years ago, learning to program was probably more relevant to 10 to 15-year-olds than it is now, unfortunately. So you see a pattern of people getting in contact that have certain needs or interests or these kind of things. And I'm sympathetic to all of that. Any contact is positive. And I'm pretty sure almost everyone that I've listed, perhaps with the, aside from Steve Brand, Steve Brand in general, but if you talk to him about an old project, he's caught up in the new project now. But I think most of us are pretty contactable.
But that's really important because most people at the professional level or other academics, right? I only need grad students, or I need an undergraduate, but I need them for exactly 10 weeks. this 10 weeks, and they need to have this skill set ahead of time. And there's a lot of barriers that I'm wondering sort of if the hobbyist community is interested in being in. Maybe that's the whole reason that they are hobbyists, is that they don't want to deal with that.
So this is an important point. In the initial example, when we were talking in the previous session, when we were talking about the biologist example of getting the biologist to come and study a simulation, overlay, what have you, the point was made that the biologist would want a justification associated with a wide variety of things. They'd want to know all these kind of things. And I made the point, and the whole notion of what was assumed. So are you hard-coding, are you predetermining these outcomes by the way that you coded it? Historically, the same kind of argument has come from fundamentalist Christians as well. So you've got a biologist, you've got a fundamentalist Christian, they're basically making the same point. My view is there are certain things that, okay, so I said I'm very open and willing. I'm not going to do your spot work for a particular thing. What I am open and willing to do is assist someone who's interested in using this, or someone who's taking it in a completely different direction. I'm fine with that. If you have curious, eccentric definitions that no like breaks, then that's something that you need to explore, or the people around you need to explore. That's not something that the hobbyist is going to do. What the hobbyist is going to do is, and this happens as well, I've got a full-time roboticist in the UK called Bob Botram who works on overlay. He's added a lot of the stuff that I've shown. He's only interested in the specific set of things. My relationship with Bob Botram is I can say, this looks interesting, this looks interesting, this looks interesting. He'll do whatever else he wants, and he'll contribute to that, and I'm fine with that. So, on some level, I think, in terms of interesting and motivating undergraduate students and potentially even graduate students, in terms of doing what they're doing for you, I don't think that's the role of the hobbyist community. However, there may be the whole notion of reinventing the wheel is something that the artificial life community and fair enough. I mean, you could argue that I reinvented aspects of Hollywood without question. But if you are interested in doing some aspect of development with artificial life, starting afresh or designing all these components that never actually fit together versus interacting with an existing project and maybe creating your own, different kind of discipline, basically. And I would advocate strongly that people actually look at the existing projects, particularly Brevet is a good example. Are we familiar with Brevet, John Klein's work? He does a screensaver on a variety of platforms of kind of evolving more code. But the underlying system is called Brevet. I want to say Artificial Life 7, Artificial Life 8, but basically he's displayed this at multiple Artificial Life conferences. He now has a family. If someone could pick up Brevet and work with that, I don't think John Klein would have any problem with that. And I think basically there are these kind of elements too. So my view is that if you can do something dramatically different, particularly with graphics, more power to you. But if you're basically creating cellular automata simulations, there are existing tools out there that do a variety of cellular automata simulations. Look to work within those. The barriers for entry are less as well. So rather than writing the C and writing all these things, you'll come to a simulation like Dolly, which does cellular automata simulation. And it will have an existing language and a graphical language and a variety of ways that you can actually write cellular automata without going and learn C if you don't want to learn C or these kind of things. So, that's probably another good point to make. Do we have any questions?
Along those lines, in my situation, I discovered Noble about 3 months ago. Tinkered with it a little bit, not much. I look at it and I think, hey, if I'm watching all the things that I want to do, what can I do now?
Okay, so what are your interests specifically? What are your interests specifically?
Agent-based simulations, I guess.
Okay, but when you see it and you say, I want to do something with it, what is it that you want to do? Or you just want to do something?
A little both. I'd say, looking at Noble as it is right now, I would say I want to add something in there besides the apes.
Mm-hmm. So this was one of the things that I put to Bob Botram. Originally, the simulation had predatory cats as well. There's a wide variety of flora and fauna in the simulation, but it's simulated through a biological simulation, which is different than the kind of distinct cognitive entities. So I put to Bob Botram, because he was interested in this as well, that the reason that the cats were removed from the simulation was that they just killed all the apes very quickly. And it wasn't particularly fun. So I pulled them out early on. But I'd like to reintroduce them, particularly now because we have three levels of brain simulation. And you would probably eliminate almost all of the narrative language element. You'd probably maintain some of the social simulation elements associated with social hierarchy and honor and these kind of things. And you would definitely maintain the cognitive simulation associated with fear and desire. You just scale them and change them. You change the underlying elements. So I put to Bob, why don't we have the cats back and also small primates as well? The slightly less than noble apes or what have you, or monkeys or something, and you put it back in. And you tweak some of the elements and you shrink the amount of language they can do, or you accentuate the fear component in their cognitive process and start manipulating that way. He had no interest in that. If that's something that interests you, I'm more than happy for you to pick that up. And I think it's something that is relatively easy to do. I mean, it's relatively easy to do if you've been developing it for 16 years, but if you come to it afresh, with about probably, well, it depends how much time you spend on it, but, looking around, and now there's additional oxygen and these kind of things, if you have background in C, you shouldn't have any problem pulling the elements together. And that's certainly a very doable part. In fact, really, that's a bona fide sub-project in terms of general level of interest. The ability also, because the noble apes are very much ground-based, the ability to start using the plant life, particularly for the smaller apes and also the cats, as an environment and actually making it far more multi-dimensional, multi-level in that interaction is all there too. So I would encourage you to make contact and to do that. And certainly I'll give you all the support. Any questions? So, in terms of artificial life, in the previous workshop space, I've got everyone to give an introduction, which made it very easy to ask these kind of questions. Do we want to introduce ourselves and then talk about it in the context? Do any of you have a sense or an interest in the hobbyist component of artificial life? Now it's been defined?
I've always looked at this. I come from a games background.
Mm-hmm.
So it's always been building simulations and that kind of moving towards actual, real simulations instead of fake ones. The games when you approximate things, you fake things to make things good, not necessarily real interactions that way. And I ran across this type of work. And then I was very interested in artificial intelligence, but it was all the top-down version. So then I saw artificial life, and okay, this is more interesting. And then I moved towards, I'm currently doing genetic programming, and I build a system to generate. But I like this idea of generating. I think I'm trying to decide what skill I want to start with. It's, the bottom being cellular automated universe having interacting. And then depending on how high...
You could kind of artificial chemistry below that as well, and like artificial origins of life.
I guess that's, yeah. So I don't know if I want to start at that area, or if I want to move more into I predefine features and different traits. That part I don't know. But definitely building a type of world where something's happening. I think my focus is I want to see a lot of emergent structures and processes. That's not something I need to sell and build.
So that is, fundamentally the essence of the artificial life hobbyist, basically, is the wonder and emergence element.
Well, and that's what I have been in academic, but not in artificial life. I think the first time I touched artificial life. I just retired as a professor of computer science at the University of Utah. But I have started in probably, and I should have bought and started from someone else's simulation. I'm interested more in the game.
It's interesting because the brain aspects, I talked with Tom Ray, I'm not sure if you're familiar with his work with Tierra. He very much is looking now at the brain. And I've said, since he did Tierra, a lot of you look at HyperNeat and these kind of simulations, dealing very much with the brain as well, in the case of hyperneat, symmetric neural networks, these kind of things, a lot of that I would say is really becoming part of it. The term artificial life is not an exact term, but I think that is now slowly encompassing with certain caveats to it. But anyway, continue.
Okay, well, I started out with thinking about how do I give it an elevator presentation? I can't really give an elevator presentation. But I guess what I started with is an agent-based simulation. It's important. I wanted to be able to develop communities, communication among agents, build communities so that they would have to build solve problems. And I wanted to do it with the simplest possible universe we could imagine.
That is difficult. You need the complexity in order to actually create the... Firstly, you have a problem where if it's sufficiently simple that the multiple places in the simulation can appear to be the same through simplicity, then you'll have immediate confusion. You need an element of uniqueness associated with the places, which means...
You can do that.
Yeah.
And you can give them numbers.
Certainly. Yes.
Which we have.
But that's almost like a brain.
So I'm talking now 10 to 20 years time horizon, which is probably beyond my activity level. But it seems to me that we are at the point where you could actually simulate. Well, okay, the name of my project is the simulation of consciousness in artificial worlds, social. You know, got a nice word out of it. So we have to build, and the only way you can get consciousness, and I know how to do information, I've shown you that ever been developed. One of the consciousness which I can't define, I don't know the definition. At huge conferences, I know I've had hundreds of those.
Well, it's one of these perfect philosophical terms for selling books, because you can create the internal paradoxes and just run with them. Question to you: how componentized is your implementation? What I've done is I've taken elements of Noble Ape and elements of Polyworld and put them together. I've taken the Noble Apes out of Noble Ape and put them in Polyworld and seen how they've interacted. And I've extracted the sea monkeys from Polyworld and put them into the Noble Ape environment. Are there elements that you could take from your simulation and put it into an existing artificial life simulation that had either the existing environment, or take an entity from the existing artificial life simulations and put them into your environment?
Probably not too easy. It's all written in Java.
Okay, well that's not a
learning mode.
Yeah.
No, but okay. My idea is to develop. Well, first you have to develop a good base so that each have to have journeys, and they have to have abilities of doing whatever they can do with the universe. The universe is a discrete. The underlying universe is very broad. If you want to get enough computational power to be somewhat close to being able to do something like consciousness, you're going to need a lot of computation power. If you're going to do evolutionary development, it's going to require a lot of computational power. So what you have to do is something like, you create a game that everyone would like to play.
So,
okay, so if you can create a game that everyone would like to play, and download it, and then everyone has their own development and say, well, I will add this type of thing or this type of component to the thing, and then so that there being the greater power. Then, of course.
So here's another question to you. Would observing the environment be also something of interest.
That would have to be.
If observing the environment was something of interest, and if you extracted that, then you would have two classes of players. You'd have the class of players that were interested just in it as visual, interest. And then you have the class of players, and that way you double or triple or quadruple your computing power, because basically you have the people that are interested in just seeing it as a screensaver, and then you have the others that are interested in tinkering. Yes.
Yeah, that's very true. I do not have that.
The visual component is also interesting because in order to make a successful game, for example, you need a certain amount of either visual imagery or a richness and complexity that will make people want to interact with it. Now, you seem to be describing the latter, but any element you can add of the former.
The former
yes.
is more important, obviously, from the point of view of getting high school kids to play it.
Certainly. The other part is... The other part that's been put to me with Barbalet is, would it be possible through something like Second Life, for example? Second Life is an open client interface. To have a node lake simulated environment with the node lakes in the environment and have you as an entity in the environment interacting with the node lakes as well.
See, I don't know anything about node lakes. I've never heard of it.
So, but in your example,
so what's a node lake? What is, this is not... To me, doesn't look very interesting.
Well, it's because, this is your problem too.
Yeah, this is exactly my problem. But this you could, if you can talk, if you can get someone from The Simpsons helping you, surely he could give you the graphics.
Yes, this is the notion of what you get with what you get. You should be thankful for what you get. So what I got was a few drawings. So the iteration is the important part. So Barbalet is basically what you've described, except the environment is complex.
Right. I think it's really important that not.
Well, I disagree because and the reason that the Bob Mottram contributed to Barbalet, the roboticist in the UK, was primarily because he saw far too much simplicity and the other environments, and he thought in order to get... So, in the previous workshop we were discussing the idea of changing single parameters. So if you had exactly the same genetically, absolutely the same contents of entities in the simulated environment, and you change the landscape to make it more harsh, and then you set the simulation to run, would the societies evolve or develop differently?
Yes.
And of course. So, but it's not that you then simplify the environment and then see how it happens. The texture, after this conference, I'm spending a week here, but then I'm going to University of Illinois to work with a paleobiologist who I've been working with for about a decade now. And he points out that actually the complexity is where the evolution takes place. That if you have a simple system, you don't have the hills to climb.
You do. If once you develop a social system, that's give you a lot of hills to climb.
But what makes...
It doesn't need a physical difficulty. You don't need complicated physics.
Well, look at isolated prisoners, for example. What you are doing is creating a completely, like a padded cell, and you're putting cognitive entities in a completely padded environment and then saying, evolve detail from this constrained environment. Whereas what you want is an environment that will motivate both physical and social evolution, but what you were talking about specifically, as I do love, is associated with social evolution.
Yeah,
and the environment is critical to that. So there is a component here, like rumours, for example. There's a thing that I'm working with currently in Barbalet associated with rumours. So the parental relationships are relatively ingrained, associated with feeding and early stage development when they're in the same presence of their parents. But after a period of time, there is an idea in the language that anecdotes could be added, and there's a rich kind of oral history component to it as well. So after a period of time, there's a potential for an anecdote to be added where your parent is not really your parent is someone else. And this you see ripple through the society and the individual in terms of how that information is passed on. So there are certain things which are related to just social groups interacting together, but the actual environment, gathering food, basic survival, all these elements which need to be relatively difficult or at least challenging in some regard. Yes. So if you have a vanilla environment where they're just basically sitting around eating flat land, not a lot of interest.
Well, you have to have something pop.
So what is the
maybe
problem?
well, you give a different body who eats easily, right? For example.
A predator.
Well, I mean, number one, you can have you can put in 500 species into the very simple unit.
So as we were talking about with the cats and the apes and what have you, the nature of predation is that the environment creates elements of that predation as well. So if you had a lion and a mouse in a box, even a particularly large box, you throw in multiple lions, multiple mice, same environment, flat, easy, the outcomes are going to be relatively clearly determined. You put a forest in there with brown foliage, weather, a lion that doesn't like particularly getting wet, you add in a variety of other factors that the environment provides, and you'll have a considerably more interesting simulation, probably something that will actually create the you want time here.
Well,
you want time and difficulty.
You definitely need time.
But I would argue that without the environment and the level of complexity in the environment, you're not going to see the elements that you want emerging.
Very well. Okay. Our idea is right now the problem is the nodes can have resources.
Mm-hmm.
So you can put in any number of resources.
Mm-hmm.
Like typically we only put in one, and they have to. If you don't eat that resource, then they're going to start. So that's the only real concern at the time. We tell the same time.
So this is Precambrian evolution fundamentally.
Well,
Finding feeding grounds.
This would be 4,000 BC. I mean,
Yes, Precambrian.
Definitely, more than 2 kilos.
Yes.
But I mean, that's all you can hope for at this point. The thing is, if you can, what you want to do is give them little problems that they have to solve, so that they have to interact, they have to cooperate. They can cooperate a lot more easily if they have communication, which is something that got mentioned in the last session by Danny. That's the important part of it. So you can have cooperation and communication.
Without question.
And the next thing is you have to build a community. Now, once you've got a community, you've got a very complicated environment. There's also the type of environment where, if you think about what causes consciousness, what's the point of being conscious? Unless you're dealing with other beings or other things that there's some good reason for you to be conscious of, so that you can understand that you and I are very similar kind of beings, right? If you don't have that, there's no real. I can't think of what the advantage of consciousness is. Why didn't it evolve? There's advantage. But as far as I know, no one has ever answered.
My understanding is it was to do with the evolution. I mean, this is why I'm meeting with a fellow in Illinois. My conversations with him indicated that it was working out feeding grounds. That was the first movement towards motivated movement and intelligence and survival. And that is the origin. Exactly. So there are origins of consciousness, I think, I mean, they're accepted at some level.
I don't think there's any
And philosophers know, because that won't sell books. But I think if you look at the...
Someone had a good solution that would solve the problem. I don't think anyone has a good idea.
So,
but my goal is to make it so that you can study, develop an environment where you can study this kind of idea with this. Without where you can study the evolution of these ideas, right? So, ultimately, I mean, there's a lot of, for example, one of the things that you read about, and you would say, well, why did outsourcing evolve? evolve all the time. Because it's really useful to cooperate. And actually, I'm not 100% so sure that you really do need communication with cooperation.
Well, it depends what your definition of communication is.
Really useful communication would develop so that you could cooperate. I think it might actually run the other way. Well, it might run both ways.
Well, communication doesn't involve speech. It just means that communication doesn't involve anything other than a means of conveying information in some fashion. But the idea of chemistry here is interesting as well. What role does simulated chemistry play in your environment? So what is your origin in terms of, is it neural networks, or how does it? So what are the building blocks?
I mean, if you want to add a neural network to James.
That sounds a little bit too complicated from what you're talking about. You're talking about more fundamental origins. So in that sense, what motivates the production of consciousness in your simulation?
Trying to keep a community. Developing communities.
Okay, but so
is the main goal. It was the first big goal.
What does your individual look like? Or entities? I mean, what is it like? What is it composed of? Or what is the? How do you define it?
Defined by the set of powers or actions
that it can take,
and what it's doing.
So those actions include like you can communicate from one to another.
Well, at this point, we haven't had it. Well, that's actually in the immediate future.
Right.
That will be probably actually within the month. But that would be good that way. We are giving the power of being able to send key messages from one to another. And they will have, but they both of them will have to have that power. Right?
And then you want them to communicate on their own, meaning you want them, what they talk about will be up to them.
Yes, right.
You just want to be like a word sort of.
Right. And presumably, I mean, at first it'll be one bit. This is good or this is bad, right? I mean, we have not worked out yet. How do you specify the location 3 steps over here? How do you get there? And as we have to develop a language for that. And there's all sorts of things that need to be developed without having. I mean, that's dealing with the physics of matter. It seems to me that that's the simpler physics as you can develop. And unless we don't have location, the simpler thing would be not to have any location at all.
So
I said I couldn't see how I viewed that complicated enough. But I thought the minimum thing that you need is location, and we use the most.
So do the entities exist as a script of components? Is that the way that you were describing them in terms
They're
of?
given a set of powers.
Okay.
The powers are all can be specified as well. Specific individuals. But
Could you describe a couple of powers?
move. I can move from here to in the direction that I'm facing to the next cell. It's a very simple idea. You can move from this cell to the neighboring cell. You can eat.
Is there an idea of a direction facing?
There is that idea, concept of direction facing, yes. But you don't have. If you work on a grid, if you make a grid type things, then you do have the concept of move left, move right, turn left, turn right. You have the concept of eat, you have the concept of consume another body if you have any. So one of our simulations we have grass, sheep, and wolves. It's surprisingly hard to get these things to work. For grass, it's and just consume the energy of it for the sheep have to eat grass. The wolves have to eat the sheep.
Certainly. In terms of moving diagonally, is there any thing?
You can choose it either way.
Okay. Is there
So
any?
you can change your grass texture.
So a movement diagonally would be an advantage rather than movement forward.
No, yeah. But either everyone can use that edge or no one can. but I mean that would be like 2 steps.
Exactly, that's the point I'm making.
We have not so far allowed any requests to have multiple steps in one turn-based.
And the advantage of Java for you is that you have a visual interface that runs on a web page or these kind of things?
Well, I don't have a web page.
Okay.
Yes, you can watch. If you put it on a grid, you can watch it. Or even if you put it on any kind of graph, you can draw the graph. You can watch where the points are moving, etc. So it's not. If you don't have if it's not grid based, or more or less grid based, it's not really would be very interesting.
So there's a fellow called Joe Riem who did Joe Riem. I'll pass on your details. Take down my details and I'll pass them on. Joe developed, I think, a simulation called Scarybug, which seems to be very, very similar to what you're describing, but it had the visual interface. So it was a grid system with so this is me, and this is my email, okay? It was a grid system, and as you've described in terms of the grass, the predation, and the bugs, he had a rule set. So what you could do is take his visual interface, because he's a graphic artist, and you could write your underlying rule structure to his visual interface. So let me see, actually, because I have the internet, I might actually be able to find it. This is it. Let's see if he might have actually pulled the underlying. Yes, I think he might have pulled it. This is someone else. But I could certainly put him in contact with you because he still has the code, and I'm sure he's actually won awards for some of his games as well. But he had as you described, grid system with bugs, grass, various food quantities. I think represented as strawberries, but these beans look like fun. And you could write the underlying principles, and I'm pretty sure it's a Java interface. I mean, the icons are discrete, so you could do what you want with it.
That could be very interesting. That's one of the problems. If you try to make something. If you try to make something that's interesting, that's visually interesting, you always have to make it 2-dimensional.
Well, you could make it. Well, you could make it 3-dimensional.
Rather than any dimension.
Yes.
Like, if we have a graph that's not really embeddable and stuff, and there's all graphs are embeddable on surfaces. The surfaces can be extremely convoluted. Actually, we've done a lot of graph fitting in the Congress.
So Jeffrey Ventrella also did things associated with previous 2D artificialized simulations mapped onto spheres. And that in and of itself provides an interesting problem space. But he has done quite a bit of work on that, and I think he's published recently on it. So I could certainly put you in contact with Jeffrey as well, because he's very interested in 2-dimensional artificial life mapped onto spheres and the interactions of
spheres aren't complicated.
Well, true.
I mean, that's easy to do.
True. Yes. But anyway.
But anyway, yes. But the idea of having someone who's got really good graphics for this kind of stuff would be very interesting. But that is my big idea. It would be nice to have other people to develop it.
So this is
I need as much support as possible.
Exactly. So this is the idea that we've discussed associated with open source, and also, working. Source Forge, GitHub, there are a wide variety of sites that will facilitate open source. Yeah, it's the one I've used and I've maintained it, but now GitHub is the new one to use.
What's the new one?
GITHUB.
GITHUB.
HUB.
in level 8, you have a 3D world where you're using 40-point positions for everybody, or is it a 3D grid? Or is it looks like you have vertical space with it.
Mm-hmm.
So it's like you're creating a grid, and this particular box has a tile with a slope on it, and the ape is in this box, and then it goes to this one?
No.
It's a full 3D thing. Okay.
Mm-hmm.
So you can't show it here.
Oh, that's the top.
The normal ape?
There.
That's okay, but that's, it doesn't look like any apes.
No, it's a point in space.
Yeah,
It's
little red guy rotates around. The little red guy right in the middle there.
that thing.
And that's his
It's an ape.
That's the
That's the ape.
This animation is using brain structure.
Yes, this is the cognitive simulation, which is the
thing is created.
yeah. No, I mean to try and do as much
So
possible.
what is the brain structure do?
So this is the what it's doing here is it has a series of sensors and actuators. Sorry, I have to run it from the command line. But it has a series of sensors and actuators that are passing information through. And based on the principles of fear and desire, the sensors and actuators. So what you're seeing is a delta. This is like a contour map of what is going through. So this is where it's dreaming, so it has a different cognitive simulation.
So you don't see the structure here, just what's going to find.
Mm-hmm, exactly. So you can actually see the clouds of information coming as they pass through.
So the brain is therefore something about 20 by 20 by 20 or something?
32 by 32 by 32. It's probably easier if I run it not from the command line. And that way I can actually
32K. And you've got a few dozen of these guys.
I've got. Well, this is what Apple and Intel used initially. Is they wanted to optimize the cognitive simulation for their specific processes. So the mathematics that goes on associated with fear and desire. So let me just pause this in an interesting point. So you can. I've got to rotate in here as well, so you can move it around and get a sense of space. And the ones that are heavily highlighted are the ones that are closest to you. So the ones that are behind are less highlighted.
So you can really see that.
Yeah, so you can get the spatial dimension and you get a sense of
what are the 3 dimensions?
that the apes actually interact in.
Well, no. That the brain. What do the 3-dimensional brain represent?
It represents agar petri dish-like substance with sensors and actuators, and it represents the information transfer between these points. So what you have is a 32 by 32 by 32 vessel with points within the vessel that are sensors and points within the vessel that are actuators. And the sensors transmit through to get to the actuators, the position responds accordingly. And they have both, well, this is kind of a 20-minute talk, but let me try and answer. I'll forward you on the paper associated with this.
But that's probably what I need.
Yeah, so, but in short, there are 2 mathematical processes that are operating. One that is associated with fear, that is, I can actually show this to you. So you can set it for just fear, and that basically is very fast reactive through the brain. And then you can set the just desire component, and that also, unfortunately, because we've already spooked it, is pretty reactive in that case. But that is so the fear component is reactive. The desire component is more associated with like long-term connection. It's difficult to describe more than that. How else would I describe desire specifically? They work against each other basically. Mm-hmm. So fear is reactive and desire is over a long period of time. And spatially, the mathematics behind them, fear is the dt and desire is a ds relationship in the cognitive simulation. But that's what you're seeing in terms of the interaction there.
Okay, so you see the emotion there,
mm-hmm.
and then but they're doing things in some other
mm-hmm.
universe that's hidden, right?
No, this is the command. Well, the way that you can access this the most easy fashion is through the command line version now. So through the command line version, you get access to the underlying elements. So you have every ape in the simulation displayed here, and from that you can get let's see, the social graph information, the underlying brain code is being run over a particular time, the vascular information.
Wow.
So basically there's an underlying biological simulation within them.
Your input set is coming from external factors and internal bodies. Right?
Exactly.
And then the output, those outputs tied to movement and like how I'm not clear on the output because obviously you're moving in certain directions, turning, but talking.
So their relationship to, as we were talking, associated with social, their relationship to other apes will motivate their movement. Their relationship to feeding grounds will motivate their movement. A variety of factors will motivate their movement. They also, so what I've showed you initially is what I call the cognitive simulation, which is the sphere desire component. There is also a social simulation, which is based on Cynthia Braswell's social robotics, where they have like a sense of honor, but also they have a sex drive, they have a social drive, they have a hunger drive, and they have one other drive. Sex, social, hunger, fatigue. And that basically is a scalar measurement associated with those factors that motivate the movement as well. They also have a narrative engine, which is both an internal language and also an external language. But in terms of an internal language, they have an idea of themselves, which is one of these programs that they run. But also, I think the 12 apes that they have most contact with, or are they have enemy relationships with, so either very strong friends or very strong enemies, they have an internal representation of what that ape is in a narrative sense as well. So all these things motivate their movement.
When you so when you start the simulation, every ape has exactly the same set of formulas and empty weights.
It's different. Okay, initially, random DNA, typically, sometimes newly improved DNA is populated. That's another thing. Their internal narrative can either be structured or wiped. There are a variety of initial characteristics that you can start with. But that's basically, and they are all the same age initially as well.
And the DNA that you're talking about, so let's take the sphere or formula, I guess is really what it is, right? Kind of one thing. The DNA represents different coefficients in that formula, but like how does everyone react with fear exactly the same way?
So the DNA is interesting. Intentionally, it's a smaller than representative DNA. So you have DNA which is not present, is not known at the time the simulation starts, but can be discovered after the fact through interrogating it. Where their ability to eat shellfish, for example, can be connected to their desire to find a mate of a particular body frame. There are a wide variety of underlying factors that all come from this genetic subset that all is fundamentally intertwined. And the way in which that was selected was done through various probabilistic elements. I can talk more about that if you're interested. But it means that the effect of DNA isn't always all positive, isn't always all negative, but is there. And typically, for long-term simulations, I will run the simulation for about 500 to 1,000 simulated years, which gives you, tens of generations worth of overlays through that. And what you see in all but really harsh social environments is really strong clans forming. It becomes like Scotland in, the Middle Ages. And from that, you have a wide variety of quite strange things that emerge. I want to add in the classic kind of SimCity, hand of God, natural disaster to eliminate some of the clans or at least perturb them. But it moves very strongly into a clan and then completely creating their own idioms kind of environment from that in very long term.
Have you ever been eating and interacted with it in real time?
So my role has always been in a godlike fashion, over the top, what have you. I'm really fascinated by the ability to do through something like Second Life and OpenSim to have a Noble Ape simulated environment. And finally, the visual rendering of the Noble Apes is the hardest thing to do. So all the stuff that goes into narrative, and you may have seen the previous screens, the episodic memory, such and such student and these kind of things, is linguistic, and it's far easier for me to generate a detailed narrative than it is to generate a picture of a Noble Ape eating a twig. That is getting the Simpsons guy involved initially, but also, I live in the San Francisco Bay Area. getting Pixar or, going and giving a talk and getting people inspired to contribute that would be absolutely wonderful. That's a dream. That's a dream kind of element.
There's an underlying world that we have here. It's a two-dimensional world.
No, it's three-dimensional. It has height and weather. And plant life also provides a dimensionality element to it as well. Yes, yeah.
That's really good.
The thing that interested me, my background is physics and philosophy. So my interests come from mathematical simulation physics and philosophy. Not biology, not computer science, not all these other elements. So in terms of the simulation element, in terms of numerical simulation, that was something that started off very early. The cognitive simulation, which is fundamentally numerical simulation, the landscape generation, the weather simulation was slightly later, and biological simulation. Biological simulation is based on quantum mechanics. So what you have is a landscape, and at any point in the landscape, you create an argument associated with probability of a tree existing there, or a mouse existing there, or some grass existing there. And you do that by saying, at this point, there is this height above sea level, there is this surface area, there is this angle to the tracking sun. There are all these things that point has, which are fundamentally mathematical components. And in combination, that gives a probability that a grass will exist at that particular point. You then have a noise map, which is either a moving noise map in the case of mice, for example, or a static noise map, which is the case of trees. And then you have, the noise map has a growth component to it as well. So that's how the trees grow, basically. Aside from the gradation, the gradients and mathematical information, there's also an underlying noise element that produces the specificity associated with a particular point. So that was the biology. Again, until Bob Mottram came to the simulation, my view with Noble Ape was there was very much about taking different simulation ideas and putting it into practice. Bob brought a lot of existing academic work that he has put with that as well, and I think the two can coexist quite well. But within that as well, for example, the internal structure, the heart rate, the blood flow algorithms, he has blood flow algorithms associated with diameters of, vesicles and what have you. He's gone into extreme lengths to create the heart rate simulation and the whole internal. Let me bring that up. I think I did that with vascular. Didn't I show you vascular? So this is not run. Let's even run it for a minute. And then maybe vascular won't be more interesting. But this shows you, for this specific ape, this is slightly more interesting. Is vascular simulation running within it. I think there's actually underlying mathematics to simplify the vascular simulation. So it interests me now, particularly from Bob's contribution, is actually getting quality time and creating new simulation methods internally for their organs in existence as well.
You've got the temperature of the blood too.
Yep. Yeah. Bob is very detail oriented.
It's nice because everyone gets to focus on the area they're interested in. But that extra thing adds, it makes your thing deeper. The area you want to look at philosophical dichotomies, this has an effect. It's not obvious. Right? It's like, this is changing.
Oh, yeah.
More
and more detail. So this is the essence of the hobbyists,
And you can run us 10,000 years of this in a week or something.
Yes.
You've got a few hundred apes.
I can't recall because the workshops and things are kind of all melding together. But I mentioned at one stage the idea, I think it was with the previous group, of historical narrative and mythology. So through the way the narrative engine works, the ape can have a representation of another ape that it's never met previously. So in real time, a group of apes go and have a dispute with another ape, come back and tell another group of apes, and then the other group of apes know about the first one. This is even more interesting over lifetimes. That you have particular apes that are eulogized and particular apes that are demonized, and these can become... So recently, a couple of days ago, I was trying to follow something in the simulation, and there was this ape that was really heavily eulogized and shared. I couldn't get access to the ape because the ape had died, 15, 20 days previous, but but still was part of a discussion that was going on, and the same exists in time as well.
So they have actually modeled the communication between the apes.
Yes.
Yeah.
So their internal narrative is not the same as, but it's the same language as their external narrative. I was working with a kind of futurist linguist fellow who was he basically said, you are your language. And he then, in kind of conversation, created a challenge that Noble Ape without language didn't explain the universe as he understood it. So, language was a necessary component. At the same time, Bob and I both had a background with Cold War. Are you familiar with Cold War and these kind of things? So the language element of Noble Ape is very much like Cold War with a few eccentricities added in. And these scripts are run basically as language, both as external communication and also this internal simulation that the apes have amongst the apes that they've had contact with.
So they actually have a conversation with the model.
Exactly. Exactly.
It's just like we do in real life.
So the interesting part about this is that when you have these eulogized apes, they will have a conversation with this eulogized ape, or at least run an interaction with that ape, which is how they continue on. So you can get the thing that interests me in this is the notion of deities, mythology, and firstly, they make mistakes through narrative, both within internal narrative and also external narrative. There's a circumstance, parental relationships are interesting. I think I used this as an example through this conversation already. But if they are told that someone who is not their parent, or someone is their parent who they previously haven't connected to as their parent, it has a very strong effect internally within them. Because basically the parental relationships, just through the constructions that I've described, are relatively strongly ingrained early on.
How is it done? Like they have a model of what they think their parent is and then you map it on top of the screen?
No. So what happens typically is they receive an anecdote with a reference to their parent that is not the person who is their parent, which has occurred either in an error in an anecdote that someone else has occurred. Error here is not a computational error, it is a mutation of the anecdote. And that in and of itself creates huge schisms. So, for example, I was doing a demonstration with a group earlier, and I counted this perfectly. One ape had, through rumour, heard that her father was not her father, and this immediately created an internal conflict because she disregarded her father. She now had a new father, and the father's narrative and her narrative with her mother, internal narrative, were contradictory, so she then started hating her mother based just on this rumour. And you could track this in process. I mean, it's a beautiful illustration. But you see these kind of interactions.
I find this, You've done that.
You see, I originally looked at this a few weeks ago. I contacted Bob Mottram because I said, I'm coming to ALIFE, I'm going to be doing this demonstration. And there's all this crazy father of such and such, which is how it represents itself. Because normally it'll just say father, but it'll say father of such and such, where such and such is the ape who's the ape. I'm like, there are these apes that hate their father, but then they say that they're friends with their father of such and such, which is them. And he said this is the phenomenon. You have a circumstance where they've been told that someone is not their father. My suspicion is that this is probably too prevalent. And the current simulation, this happens as well, where you see certain things which are just statistically too prevalent, and then, things need to be altered because it's the whole notion of language, and particularly if you look at Core War as an idea, what we are doing here, we've kind of taken a subset of Core War and added other elements. For example, there are sensor and actuator components which are very similar to Core War's mathematical operators anyway. There's a data component which is identical to Core War's data component. But there are additional elements that Bob has added, and one of them is associated with anecdote, which has a different prevalence in the way in which the script is propagated. And my suspicion is that the anecdote, particularly associated with parents, it's just too strong currently. So what we could be seeing, and what is used as an example here, but you're also, here's the other thing. When that happens to the ape, the way in which you find the ape, which isn't good currently because it's not, let me run it for 10 days while I'm talking. There's a hierarchy that the simulation creates, but Bob created a kind of scale hierarchy associated with epic, which is you are being talked about. So the ape which has the most conversation about it is promoted to the top of the epic graph. So funnily enough, the apes that are typically promoted to the top of the epic graph are also the apes that discover that their parents aren't their parents. So there's a kind of false thing where in the simulation of 100 apes, the ones that I keep seeing are the ones that had this factor. So really, percentile-wise, 1% total simulation. Actual effect-wise propagates them up because all the other apes communicate. So there are all these kind of things where you get these effects, and then you have to say, is it a tuning issue, or is it a propagation issue? Is it because you're just looking at that specific ape that is propagated through these things? And the metrics that you have to create a social hierarchy promote that. The other thing is honour, and honour is separate. Honour was originally a grooming idea. It's a social currency. So one ape would groom another ape, and their honour would increase. And that while they didn't have any primary access to their honour, the other apes had a general sense of how honourable the ape was. It's kind of ethereal quality that's mapped onto something. This was very much Bob Mottram's introduction to Noble Ape, and it comes from social robotics from Cynthia again. It then started developing quite an interesting metaphor. There's almost a kind of alpha-like quality in the honour. But you can create a social hierarchy that has honour as its basis, and you get a different social hierarchy than being talked about most. And the point I made to the fellow earlier, the biologist earlier, was that you can create your own social hierarchy functions and see whichever comes up top. It's not necessarily that there's a natural social hierarchy, because honour is one thing, being talked about is another thing. You could probably try to convolute both of them, but basically they exist as separate entities.
You can control C. You're doing a lot more than
So this is the other thing that...
certainly at one point it's going to be like, oh, I just...
Yeah, I've heard a lot of Noble Apes in my time. I don't sleep any harder at night knowing that they're dead. Yeah, just, I mean, these kind of things are interesting as well. The movement into robotics, I think, is very interesting. So I think Bob Mottram come to me from robotics and develop software, but I think the movement from this into robotics is interesting as well. The hobbyist robotics community is really, I think, the artificial life hobbyist community needs to look at the hobbyist robotics community as a really vibrant and distinct entity from the industrial robotics community. And I think that's something that's interesting as well. Are you kind of familiar with the hobbyist robotics community? So, I mean, there are magazines and things that you may see in passing, but it's very much the idea that anyone can build a robot, anyone can write the underlying logic, anyone can start, programming it remotely and these kind of things. And it's basically an empowering, technical movement associated with getting people building robots. And I think, the artificial life hobby has a bit of a similar element to it as well. We were talking in the first workshop associated with the web artificial life academic community, and how there's now a hobbyist web artificial life community, which is distinctly different, but again motivating people potentially into web artificial life academia as well. Anyway, I'm not sure. Set it to run for 10 days, and this may be a little bit too long to actually illustrate. But I can show you the epic and.
It's done in over 7 days.
Yeah, at least 7 days. There we go. So you can see these are the top honor apes, and these are the most talked about apes, and these are actually distinctly different groups. There's actually not a lot of conversing about specific apes going on currently. After 10 days, sometimes, and this is typically in correct false parent case, you will have epic numbers of 100 plus, because really that kind of information just travels like wildfire. Again, back to the points associated with your specific simulation, the complexity of the land environments and the weather and all these underlying conditions affects the social interactions, not just in terms of feeding grounds, but also kind of, affects additional effects, basically. Their relationship to territorial space and these kind of things is really important, but relates directly to land surface and the biology that exists in the particular areas, particular rock pools, these kind of things in terms of their interaction. And I think I do have a version of the simulation which just provides a flat land with no weather, with the apes running around, and they very quickly start doing things that you see with kind of caged animals. They'll start running in circles and doing these kind of things, and it really is quite curious that the lack of rich environment.
So how do they decide what they're going to do next?
Well, they're motivated by a variety of factors. They're initially, it's difficult to describe in language, but they have a need for exploration. They also have an underlying hunger need. They have, as I illustrated.
Whatever need dominates.
So yes, here we have hunger, fatigue, social, sex. And these are relieved through different things and different interactions, and the dominant need. Hunger can't be overridden, basically. Hunger and exhaustion basically create circumstances, hunger and fatigue, social creates circumstances as well, but hunger primarily and fatigue are two elements that can't be withheld. They have to eat after a period of time. If they're in water, it becomes even more interesting. They have to find land. Typically, there are certain circumstances of panic and these kind of things that can come through the environment as well. It progresses, through their existence.
So you've got a location, you've got what direction they're facing.
Mm-hmm.
You've got what drives they have to satisfy. Body attention, so that's what they're thinking about.
Yes.
And the relationship attention.
Which is what they're thinking, yes.
And this one has been thinking about a granddaughter only in the whole 10 days.
Actually?
Well, just about. Friends and enemies.
The episodic memory.
That's what they remember. So sometimes that goes away.
Mm-hmm. Well, it's based on waiting.
Something that they do at least now is directly to episodic memory.
Mm-hmm. And then waiting is based on the
nature of language, but then they have their own internal language. How many things do they?
Okay, so they have 12 including themselves. 12 entities including themselves. So the entities are typically populated by the friends and enemies list, and this ape just doesn't have a particularly large friends and enemies list at this time. If we went to, let's see whether we'll talk about apes. So, no, there's not so many.
And these are the internal models.
Mm-hmm. So when they have interactions with the external, it obviously informs their internal model too.
Does it use the internal as a filter to the external, or is it talk to the external or
It's talk to the external, it's talk to the external up to the internal, but there's also, it's, in terms of the underlying narrative is a comparison of two things at every time. So typically what it is when they're interacting with the external, I think it is the external communicating with their internal view of the external, which is then communicated internally within them. So basically it's a one-to-one mapping of an execution together, and then the...
So it's like a perception filter.
Yes. I think I've got that right. Yeah.
Could be either,
Yeah, so there's always a comparison. Yes. Yes, and then, which means that there are certain circumstances, belief is an interesting term in this context, there's a certain circumstance where the internal code will take dominance over the external code because it's run in parallel, and as with Cold War, you have those kind of patterns, basically. Yes,
the memory is very much like what they can say to each other.
The episodic memory can be accessed through... Okay, so as with Cold War, the episodic memory is a data access that it can then reintroduce into the program and communicate. So, yes, they have access to the episodic memory, and their access to the episodic memory is through this script, which they then can communicate. So, in the case of the parent anecdote, my assertion, still working on it, is that that has a dominance in the narrative engine communication that then propagates it through, pass through multiple aids, so it becomes an ongoing anecdote, rumour that's circulating.
I haven't seen anything about parents in the episode.
So here, for example, unless the parents are explicitly stated, typically if the parents are here. Okay, so the way the simulation starts is that they're all the same age. Their relationships with parents come through interaction and recollection of an ape that is born through the simulation and raised by parents will have an immediate parent relationship by their interaction, which is reinforced by their interaction. But what you have here is a group of adult apes that are mysteriously thrust in this simulation. So, yes. Which is curious as well because for the first generation cycle, even the second generation cycle, you will have them having relationships with apes that don't necessarily exist in the simulation. So the ape that was concerned about granddaughter may not have actually had a granddaughter that existed in the simulation. It is just a... Similarly, it gets much more interesting when you actually have the family relationships within the simulation. It creates another level. In terms of the movement to kind of plans and these kind of things, my view is that what you have there is kind of superpositioning of family relationships on everything, almost a kind of crippling based on family relationships. And then I was running the simulation when I went and came back recently, and you had these kind of clusters of children around parents and these kind of things. They were young children, we can select and see. But, this very much kind of socializes a family oriented, which becomes plans more broadly.
How long did it do?
Through natural causes, about 32 simulated years, based on defects up to about 48 simulated years.
And this was just 10 days or 10 weeks?
This was just 10 days. Yeah.
Can you zoom in on that?
I can use the power that Apple gives me to zoom. What aspect in particular are you interested in?
I see an ape walk around.
Okay.
Yeah. It's very interesting. And you see some nice motion just from top to.
Okay, let me simulate for 10 days, and then the problem is it runs faster through the command line. So let me see if I can actually run another instance. I think I'm not. Yeah, it was the same one. Actually, no, it won't like that. It's the same one. I'll quit out of this one and run another. So this is the initial boot up exploration. This is a new ape to the island, new brain information, and the ape is just exploring initially. Going into the water, swimming across, getting a sense of the space, not yet stopping for feeding. This is the energy. When the energy gets to about here, they have to start feeding, basically. And this is their speed. So as they're swimming, they slow down. As they get onto land, they speed up. Now it's eating there. Through more information, you can see specifically what they were eating, but they are eating something from the biological environment, and now they're asleep. So really, the reason I run the simulation for 10 days is 10 days is a good amount of time for them actually to start doing initial interaction, start getting a sense of the land environment, to start actually providing information because they've interacted with other apes at that point. Slowly but surely, if you run it for... they are born at the age of maturity, which means that they can have children from then on. So you also start having the introduction of children through that time. If you run it for a year or two, you start seeing the kind of children develop, basically, and so it goes on. There's a parameter, I think, a lot of that is actually compressed, associated with suckling and all that period, but we'll put all that in. So there are social events associated with all those things. So the child, the infant Barbalet, will mainly have like suckling events and these kind of things, which creates a parental bond as well. So both the association, the suckling, There's a general nurturing event, there's a kind of tethering period where the parents take around the children, and a general level of protection. What you can do is, well, you can kill off a parent, you can do various other things, and you can force drowning events, but you can also just remove them from the simulation. And you can then see how the child develops, whether they take foster parents, whether there's a kind of community development, all these kind of things from the simulation.
How do they do just a vanishing? Let's say there's a mom and daughter.
Mm-hmm.
The mom just vanishes. The daughter.
Well, the daughter maintains the memory of the mother,
Yeah.
but basically her relationship with the mother changes dramatically over time.
Is it the same as the death because the death just disappears body as well? Or is there a remaining body?
No, there is. That's an interesting thing. The mourning process associated with the remaining body is an interesting thing. It's not done in the simulation; they just disappear, and that, I think, would actually produce something that was very interesting. Exactly. Yeah. That's a very good point. I'll certainly consider putting that in there because that's a really good addition. You would then have things like social burial or what have you. This ape is actually in a state of panic, but just on the land and fallen asleep, exhausted. Yeah. So no, death and mourning would be a really interesting addition in terms of actually maintaining the body. And that is a very interesting addition because a lot of the mythology is associated with the disappearance as well. They maintain it because there isn't an entity there. And if there was an entity there, it was just deceased. It would have a different impact. So that is very interesting.
So how do they decide what it's going to do next?
As I described, there are a variety of factors that contribute to movement.
But these are all deterministic and
So as you see here, it's not particularly good for this example, but typically what it will do is show immediately what its considerations are. So here obviously it's sleeping, so its immediate consideration is shown. But sometimes you will have 3 or 4 things that are within its immediate consideration. So it may be related to, so for example, procreating, finding a mate, these kind of things, relatively self-evident if there is a mate present. If there's not a mate present, then that in itself becomes a drive to go into an area where it may suspect where it's seen the mate previously. Eating is similar. They will find territorial feeding grounds and they will return to those feeding grounds.
Yeah, so you've got several different drives.
Mm-hmm.
How do you determine which one's family? You just then work on the numbers of each?
So the drives are motivating rather than eating and fatigue are basically dominant drives. If they are, and eating,
so
both eating and
if it wants to eat, it does it first. If it doesn't want to eat, then it chooses, and it's not, or if it gets, presumably excitement and fear, it probably eats eating.
mm-hmm.
But you have a hierarchy in the system. So you check the first condition first, and you decide to do that one.
It's not quite that simple. Because after eating and fatigue, well, basically they're resolved in the same way. I don't think there's any condition where the noble ape will sleep due to exhaustion during the day. They may stop moving and rest, but they won't sleep due to exhaustion during the day. If they're hungry, they'll seek out food, unless they're in a circumstance where they can't seek out food. And then, in certain circumstances, we saw there's potential for them to get into a panic. After that, there are more subtle factors that affect it rather than just simple, here's a hierarchy. And aside from the drives, also elements of their narrative. I mean, it can become, when they pick up rocks and they do these kind of things, there are a variety of things that they do that are more part of their internal narrative than anything else. So they have a certain amount of free time, which typically they'll initially use for exploration. But then, as they interact with other apes and what have you, they have a narrative. I mean, they can brandish sticks, they can do a wide variety of things. They can, practice fighting, practice doing a wide variety, which is done on the linguistic level, fundamentally. So it's not it's their internal narrative.
That's occurring when these 4 are good to go. Not even necessarily, they're kind of related.
So if you see with the sex drive, for example, the sex drive typically, after a long period of time, unless they haven't found a mate, remains high.
Well, let's say everything's kind of in okay state. Is that when their internal narrative and playing around with stuff.
Yeah.
Trying to figure out.
So, yeah, if you think about, yes, very much so. So after the immediate and eating and rest to the immediate, then the drives are interesting to describe because they're not a priority, they're a kind of long-term, they're not something that motivates priority initially, they're something they can access through the narrative, but they're not something that will actually motivate anything. And they're, I think there's some interesting kind of the anthropology of node-late mating. I think there's something there. I think there's an anthropology of these things, which is not defined explicitly, but comes through the narrative. So you could create a simulation where, based on underlying land factors and perhaps where you group the apes initially, where they would have social dance is an interesting phenomenon. Okay, through free time, they do a variety of movements, both socially and on their own. These movements can become reinforced. Okay, these movements can then be connected to perception and mating rights. They have an underlying genetic element associated with finding mates as well. They have underlying preferences and tastes, which are genetic. And that's very interesting in and of itself, powerful to find mates. But there's no hierarchy that says their genetic preferences versus the narrative. They're intertwined, basically. And it's elements from both that will, move them towards particular entities. And so they have a particular interest in an ape, and then they hear a narrative which makes that ape seem negative. So that's something in addition that affects it. It's not just a single cause, it's a multi-layer kind of cause and effect problem.
Is it deterministic or random?
So it's this is an interesting question. Each ape contains a random element. The environment, and this is to do with running it over distributed processes, the environment appears to be random but isn't. You can start from the same place. So the idea is that you can split the apes over multiple processes and you can run the simulation independently or on one of these processes and you will get the same results. And the way that you do that is by having a deterministic environmental simulation, and it is fundamentally deterministic, but the random number generator is the interesting part of that. So I've gone through 3 different random number generators associated with Barbalet that I've handcrafted initially and then worked under very specific requirements for. But it is, in terms of putting in the same seed, same outcomes, it's deterministic in that fact.
Okay.
But in terms of the underlying, that's because you know the random everywhere through. If you don't know the random at one place, then it is random.
Okay, so you are, it is random. So the 8th viewpoint is
very random.
What you're going to do next? We don't know.
Well, yes. The elements that would affect them in that light associated with random are interesting in and of themselves. I don't think it's strictly a randomizing factor because there are strengths in the underlying narrative, as we were talking about every aspect. It's not that it will just be one specifically, it will be that they all have components. So, yes, there are random elements to that, but there are points where their hunger or elements of narrative or what have you are above the kind of random threshold that would change their movement. It's very interesting, actually, what I've done is taken a simulation, save it, and changed one of the apes' random numbers by just enough, a single amount, which obviously propagates very quickly. But when you look at that over time, and you can track it over time and how they move differently, they basically, for probably the first 20 to 30 minutes, you don't really see anything out of the ordinary. They may move a slightly different path, they may move in a slightly different direction, but then after about an hour, they're typically sufficiently different that they will be doing something completely different. But that isn't so much it's just the subtle elements of random kind of piecing together in that.
So, but I'm just putting
Keeps me off the streets. I'm not sure when we're supposed to wrap this thing up. Okay, so
that's close enough.
Let's call it a day. Been a pleasure. Thank you.
Thanks. interesting question for a godlike figure. Create a whole universe where you get to control C. Is he a mass murderer? I mean, he made it.
Yeah, I don't think so.
The eternal narrative.
Thanks.
We'll talk to each other.
Yes.
How big is the language?
I think it's about 67 commands, I think. It's of that order. And it's a space of, I think, 250 bytes per entity. So it's a relatively small amount, but it's enough to... It's always been... well, here's the interesting thing. So with code wars, the core wars, it has to be a byte orientation. I have an additional scripting language called 8-script, where it's, I think, 32, could be even 64-bit limited. And my view is that the brain code needs to move into 8-script in the long term. 8-script is also human readable, and it's stable. So I think there will be a movement from the narrative engine, which internally is called brain code, into 8-script, probably within the next year or so. And that would give a far greater, but with greater space comes a wide variety of additional factors. And it's not a one-to-one mapping in terms of what it'll add. But I certainly, as a kind of midterm project, have a serious interest in actually changing what the narrative engine part is doing, particularly kind of human readable. I mean, it does produce core war style bytecode. I showed it previously, but it does produce core war style bytecode. Aside from the numerical versions, I got the bytecode that you can read, but it's not human readable.
Yeah, but if you just change those bytes into words.
Mm-hmm. But it's still relatively abstract. The benefit of AlifeScript is it's a C-like language, which can even then be added. You can then add proper narrative to that. I mean, it's close enough to, it's not human language, it's C-like in terms of the structure. But you can then describe that in a, if this, then that, then this, then that, then, while, and these kind of things. So it's slightly easier to read than the bytecodes. But yeah, that's another medium-term project.
Yeah, but it's just that communication. Wait, understand how you turn in the language.
Mm-hmm.
So I'm talking about when he talks to the other.
Mm-hmm. So there are two bytecodes that are processed in parallel, and they're then exchanged.
Okay, so
the
two-way conversation.
The processing, yes, creates
always a two-way conversation.
Yeah. This is the whole reason that they have internal associated with internal representations and external. So they can have coherent internal conversations as well.
And then those statements can go into the memory, into the
episodic memory.
Memory that they have.
The episodic memory is actually, aside from the small number of cases, populated by external events, though. So if they have a conflict, for example, with another array, or if they eat something, or these kind of things, these are very much external events that are in the
They can be put into the episodic.
Exactly.
So they have to be describable.
Certainly, in some regard, yeah. They have a space-time kind of footprint, so, well, also weighting associated with the strength of the episodic memory. So the birth of a child, for example, or these kind of things is relatively strong. You have a twin.
Right. If they had a birth, then they would remember that probably for a year.
Mm-hmm.
Nothing else, but most things they only remember it for days.
Yeah, less than days in some circumstances. If they have a lot of interesting stuff happening in a day, they'll forget things.
Because they only have so much memory.
Certainly.
Is there currently any narrative going on external from any? Like, could I say this twig is heavy? Or is it only more like that 8 branches twig?
What is described through narrative is the interaction. But in interacting, you create something that describes what has occurred as well. So, because the underlying biology is representing quantum mechanics, the twig doesn't really have an existence until it's interacted with in that fashion. So, in that case, yes, things develop an existence through narrative of the level of twigs. External apes, to a certain extent, exist.
Okay, so it would be more like this ape thinks this twig is heavy.
Mm-hmm.
That's more would be like that.
Mm-hmm.
But they do understand that they're thinking in that
so this is the interesting of double touch.
Yeah.
So you want to be able to do this and understand that you're touching as well.
Do they know that they know?
That's very interesting. So there was some discussion associated with this with narrative. Because they have an internal representation of themselves, they have a notion of self, which is primary.
Do they have the concept of know?
I
mean, is that one of the verbs?
They have a concept, but I guess, of validity, which is kind of like no, in some regard. Or, well, it's a referential validity.
Well,
I don't know, it's kind of deeper philosophical mapping.
so do they have the concept of falsehood?
As I wrote it originally, the noble apes were very trusting, and they didn't have the concept of falsehood, but I think they do now through narrative. So I'm pretty clear that they have a concept that what is being told to them is not true, so that is falsehood.
Yes, so then they do have the concept of falsehood.
Mm-hmm.
So, and that's why.
And they make judgments
that's why
based on that too.
They can believe contradictory things.
Exactly. Yeah.
But they simply recognize them. Or do they recognize
Well, okay. So in the case of the false parent,
yeah, that's what
there was a circumstance of no, they can't. Well, they recognise it's a problem. What's represented to us is their true parent and their false parent. So we know by looking at it, so and so is their father, and so has been represented as the father of them, but isn't. We know that looking at it. But what you'll typically find is that they will be repellent from their true parents when they discover it. So they're I think in all cases that I've observed, if they're given information from a source that they trust that contradicts what they have internally, that they will believe more readily the source that they trust if they really trust that source. Now they recognise this, I think, is to do with propagation of the rumour. Why the apes that are the most talked about tend to have these kind of turmoils within them. So they're aware of the contradiction on some level, but this is actually probably kind of taking note like, yeah, this is more deep philosophy that I haven't really thought through.
But they won't actually know who the parent is in the book.
No, that's exactly the point.
So they only know something if they're told.
Mm-hmm. Or through
they did it.
Or through interaction. I think the suffering interaction is primary associated with parents, and my sense, this is deeper. This is more Bottrum's side of things than is my side of things in terms of the specifics associated with this. But my understanding through observation associated with this is that if they are born and they're suckled and they are reared, they will know through certain things. The discussion I've had with Bob I think related to pheromones specifically, but there are contact ways in early childhood that establish parents. Now, this is displayed to us as specifically parents. What the ape themselves internally, coherently understands is this. I think currently through brain code probably could be intuitive, but is relatively unintelligible for us observing the simulation. You could dump the brain code and then go through it and actually analyze it, but the level of granularity that you're displayed is so-and-so is their father, so-and-so has been told is their father, this is their relationship with those two entities. Mm-hmm. Aside from that, you need to go into the brain code basically to understand what was actually going on. And I don't think that's the need for a natural language brain code. You could go into it. I've watched and I've done slow decodings of this, but in real time or even, I think these kind of paradoxes should be studied further, because it is interesting, and it would probably expose, other things that are either flaws or strengths, basically.
Yeah.
It's a never-ending process.
I mean, what can you? How do they know? What do they know? But you've got the episodic memory,
Mm-hmm.
but there's other things remembered in their brain at a deeper level.
So they have access to the episodic memory through the narrative engine. So it is, yes, it is.
So they know the parents other than through the episodic memory.
Yes.
By having that mind.
Yes.
Yeah. So if you think that was dumb, they don't know the episodic memory.
Unless they trust the entity that has given them the information, in which case it creates a term, which the other apes talk about as well.
So the original fact is based on their own internal trust of themselves.
It's based on suckling events, I seem to recall. This again is Bob Mortram's heavily in there, but my recollection is that various primary points of contact reinforce parental relationships. But after that, this can be perturbed by narrative. And there are circumstances where you could potentially, although it would need to be a suckling mother, you could kill off a mother in the simulation and then see if the orphan ape would gravitate towards another suckling female and how that interaction would take place. And in that case, I'm pretty certain that the interactions, if it was permissible by the mother or by the foster mother, that would create interesting relationships as well.
You need to be able to watch these tapes in real time.
Yes, you need local detail, but it's very difficult. I mean, this is the thing, not just graphical detail, you need to have an internal narrative, which you need to watch it in slower than real time, fundamentally, because that would be the time that you would be able to absorb the full level of detail that you need.
Well, you could just slow things down.
Exactly.
If you wanted to see something in detail.
Yeah, a zoom and slow.
But I think the problem would be still today, you wouldn't have the computational power to do it.
No, I don't think the problem is computation. I mean, as you noted, when you don't have the power, you just add the numbers in terms of processing and what have you.
And you wait. And part of the problem is you want to see what's going to happen 5 years from now.
Certainly.
You don't want to lose 5 years.
But you also want to know what's happened 5 years previously as well.
Yes, so now you've got to have a lot of memory. Because you don't have to remember the whole thing.
Yes, if it's, exactly.
You don't. You only have to remember one instant here, one instant there.
You
can extrapolate between.
Yes, you need to know some of the random elements. You need to know the random.
The random numbers. It's not so easy to keep the randomness.
It is.
Across the whole thing.
You just need to know the points where storing the random is important. And then you kind of carry that shadow of randomness through, and then you can repopulate based on that.
Right, but you have to have multiple points.
Of course. Yeah.
Well. Thank you very much.
Not a problem.
Let's introduce myself.
Okay.
Joe Horn.
Tom Barbalet. Pleasure to meet you.
Good to meet you.
So, yes, you have my contact details, so
yes.
Be in touch.
Yeah, well, once I have your name, I can...
Yes, it's a unique name.
And since you're all over the program, that's good.